Hi, this is Ms. Skyford. This is our first video of the year for Unit 1 on real numbers. What I like to do is go over some practice problems that we've done in class, just so you can remind yourself of how to solve these problems and what the questions are asking. These videos are great for using to study for quizzes and tests. So I'm going to call this your video lesson. And I'm going to write it real big. This is for 8.NS.1. So that's the standard that we've been working on for the past week and a half or so. And that's going to be a big part of our unit test coming up soon. So here we go. Let me give you some examples of what this all looks like. So we've been talking a lot about square roots. All right, just to remind you, what is a square root? A square root is a number that's been multiplied by itself. Okay, so for instance, 4, I would multiply it by itself. So 4 times 4 gives me 16. So when they ask you, what is the square root of 16? Because 4 and 4 give you 16, the answer is 4. We have things called perfect squares. Now, perfect squares is that list that I gave you in class, but it's all of your doubles. Okay, so 1 times 1, 2 times 2, 3 times 3, 4 times 4. All right, so this would be 1, that's 4, that's 9, that's 16. So anytime they square these numbers, or they put a perfect square root over it, so for instance, 9, the answer is what its double is. So the answer here would be 3. All right, so let's try if you have a negative, for instance. So let's call this example 1. All right, I have a set of parentheses here with a negative 7 inside, and I'm going to square it. That means I'm going to write negative 7 2 times. So negative 7 times negative 7. All right, well, 7 times 7 is 49. And a negative make a positive. So my answer here is 49. All right, let's look at another example. Example 2. Example 2 I'm going to show you is 9 negative raised to the second power. If you notice, this one does not have parentheses. So when I actually break this one down, it's negative 9 times 9. So when I go to solve for this one, 9 times 9 gives me 81. And then a negative times a positive equals a negative. So this one's negative. So do know the difference between these two. Parentheses, answer is positive. No parentheses, answer will be negative. All right, let's try another example. Call this one example 3. What if you have a fraction? So for instance, 9/16. What is the square root of 9/16? So the best way to do this is to break it into 2 separate square roots. So you're going to take the square root of 9 and then the square root of 16. So the square root of 9 is 3 and the square root of 16 is 4. All right. Now, I know in class I've shown you how to use your calculator, so I'm just going to pull up my calculator real quick here. All right. Let's see if I can come back to my canvas here. All right. Actually, let me see if I can make this a little bit smaller. There we go. All right. Well, on our calculator, there it goes. What you want to do is, using our keys here that I've shown you in class, we have, this is to square it and this is to square root it. So what you want to do is type in 9 and hit the square root, and that's how I know the answer is 3. 16 and hit the square root, and that's how I knew the answer was 4. To go in the opposite direction, if you're squaring the number, like we did before, you could say 4 squared squared gives me 16. 3 squared gives me 9. So know how to use those two keys on your calculators. All right, so let's come on back to my white screen here. So let's try example 4. Negative 3 times the square root of 225 plus 10. So now we're not just dealing with one particular problem. We have some things to solve here. Remember, anytime you have a number outside of a square root or parentheses or attached to a variable, that means to multiply. But first, I need to get rid of this square root. So the square root of 225, you can check it on your calculator, but it's 15. So I'm going to do negative 3 times 15 because this means to multiply, but now I'm done with the square root, and I'm going to bring down that plus 10. All right, so now let's multiply these two together because if you remember order of operations, you multiply before you add. So negative 3 times 15 gives me negative 45, and bring down the plus 10. Now you have a negative and a positive here, which means you're going to subtract these and keep the bigger sign. So basically 45 take away 10 gives me 35, and my negative was the largest number, so my answer is negative, and that is your final answer there. Now again, we get into solving more problems where you have to do 2 or more steps. So let's call this example 5. I have 9 squared plus 3 squared. So I'm going to square the 9, so that's 9 times 9, which is going to give me 81, plus 3 squared, that's going to be 3 times 3, which is going to give me 9. All right, now you just go ahead and add these up. So 81 plus 9 gives me 90. Let's try example 6. Same thing as if you have a fraction. If the whole fraction is inside a group of parentheses, you're going to square the 5 and square the 6. So if you kind of want to take it out of parentheses to look at it this way, you could say 5 squared and 6 squared. All right, well 5 squared is 25. 6 squared is 36. And that's your final answer. Example 7. 5 squared plus root 49 64ths. So a couple things to do here. Of course, order of operations. Let's go ahead and take care of that exponent first. So 5 squared is actually 25. Bring down my plus. And now I'm going to square root both of these. If you remember, you can kind of think of it as 2 separate square roots. So the square root of 49 is 7. And the square root of 64 is 8. Now, I know fractions tend to throw kids off a lot, but this one's actually pretty easy because this is a whole number. This is a fraction. If this is a whole number and you have a fraction, you just stick them together. So this becomes 25 and 7/8. You don't need to find common denominators because this is a whole number. It's not a fraction. The only time you find common denominators is if this was an actual fraction. All right, let's try another one. Example 8, I'm on. Square root of 62. All right, so I'm going to jump over to my calculator real quick because I want to show you how this works. All right, so if I did 62 and I hit the square root, you get this crazy long decimal. That means 62 is not a perfect square. So what I can do is if the question's asking where does 62 fall between, like what two numbers does it fall between on a number line, that's when you're going to look at this decimal here, and what you're going to look for is, can this round? So 7.8, yes, that can round up to 8. So I would say this is between 7 and 8. You would not say between 8 and 9 because that's not big enough to ever become a 9. 7 is where it starts, 8 is where it ends. All right, so to look at this more clearly here, let me rewrite it. 62. What I would want you to do is say it came out to 7.874, and then give me the dots. That means that the decimal kept going on forever. Now, because it's asking you to estimate or to find out what it's closest to, you want to use your about symbol. So this is about 8. All right, let's try the same thing for example 9. Square root of 122. All right, so let's do that. 122 square root, and there's my crazy decimal. All right, so let's write that down. This came out to 11.045. Continue. So I'm going to round it to 11. That 0 is not big enough to change that 11 to a 12, so it stays just like that. All right, now a couple of my groups got into cube roots. A couple of you did more than the other. So in this video, if you weren't one of the groups that did a lot of cube roots in your stations, hopefully this video will help you with just the basics. So example 10. Now a cube root is when you take a number and you raise it to the third power because it's 3-dimensional. So if something's raised to the second power, that's 2-dimensional. 3-dimensional. All right. Now, of course, if you get into 4 and 5, you're talking about, physics and black holes and such. So most of the time, we just stick to these as far as squaring and cubing. All right. That means that a number is multiplied by itself 3 times. Not times 3, but 3 times. So, for instance, 4 to the third power is 4 times 4 times 4. And then 4 times 4 gives me 16. 16 times 4 gives me 64. So if I say 4 to the third power, I would say equals 64. Or, let me change colors here. If I say the cube root of 64 is 4. Now, one thing that you want to make sure you do is you include this little 3 right here on your root. Because without that 3, you're telling me the square root of 64 is 4. So always make sure you have that little 3. So now let's actually do number 10. My example for number 10 is 6 cubed. All right, so let's go back to our calculator here because I want to show you how to use this. So now we're going to look at this key to cube it, which is what I'm going to do right here. And then this one is your cube root. So if you're not using an iPhone, you just want to make sure you find those keys on your scientific calculator. All right? I'm just going to erase that real quick. Because when I get rid of my calculator here, my writing will show up. All right. So 6 cubed is going to give me 216. And that's your answer there. So now let's go in the other direction. For example, 11. What if I took the cube root of 2,744? And you're probably thinking, holy cow, that's big. All right, well, let's do this. 2744, and this time I'm going to hit the cube root. And my answer is 14. So when I come back to my problem here, I'm going to put equals 14. And that's your final answer there. Now, sometimes, as we saw before, not all of your square roots are going to be perfect. Not all your cube roots will be perfect. So you may have to do what they call simplify. All right? Now, simplify means to break it down as far as you can go. So I'm going to do this one as an example here. For example 12, I think that's the number I'm on here. What if I gave you the square root of 44? All right, so if I had my calculator, I could do 44, and I square it. Oh my goodness, I get this huge long decimal, so that's not going to help me. So what do I do after that? So I'm going to get my problem back over here. You want to think of all your perfect squares. We have 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, 5 times 5, which is 25. 6 times 6, which is 36. 7 times 7, 49. 8 times 8, 64. And I could keep going on. I want to know, is there a number, one of these perfects? So one of the ones I'm underlining here, are any of these numbers divisible by 44? So what that looks like is this. Let me see. You're going to grab your calculator now because that didn't work out. Grab your calculator. And you're now going to say 44 divided by, and let's try our first perfect square, 4. Oh, 11 times 4. That could work. Now you want to check a few more that are higher than that just to make sure you simplified all the way. So what if I did 44 divided by 9? Nope, not going to work. 44 divided by 16. Not going to work. You got a decimal. Even though it terminates, you still got a decimal. 44 divided by 25. Not going to work. 44, last one I could check is this one, 36. Not going to work. I'm not going to try these other ones because they're larger than the number I have. So you can't go past 44. So I can't divide that by 144 or 121 because the number's only 44. So the only one that worked out was that 11 times 4. So we're now going to rewrite it as the square root of 11 times 4. Now, the only number here that is a perfect square is your 4. The 11 is not, but that's okay. We're going to cross out the 4. What is the square root of 4? It's 2. So you're going to drop a 2 down, put the root, and then what's left? 11. That's it. That's your final answer. You cannot simplify any further than that because it's not a perfect square root. Let's try another one. I'm actually going to leave my list up, so let me just erase real quick here. Instead of clearing the whole screen, I'll just erase. That we don't have to rewrite that whole list again. All right, example 13. We have the square root of 288. And I'm going to just tell you right now that 288 square root is not going to be perfect. So I'm going to come back over here. And I'm going to start taking this number and dividing it by these numbers. Now, since this is in the 200s, I can go past this. So let me just keep my list going here. 9 times 9 is 81. 10 times 10 is 100. Not sure why my pen keeps grabbing there when I do my equals. 11 times 11 is 121. And 12 times 12 is 144. I'm going to stop there. Because when I get into 13, I am starting to get to numbers that are a little bit too big. Oops, 169. And if I go past 200, then it's not going to work anyways. So let's take our calculator. Okay, what we're going to do is take 288, and we're going to start dividing by the largest number we have. So let's go ahead and do 169. So divide by 169. Not going to work. 288 divided by 144. Oh, we have a winner. So I don't have to go through all of the perfect squares because my largest perfect square so far is working. So let's come on back to the canvas here. And we're going to say that this is now the square root of 144 times 2. 144 is my perfect square. It's 12. So I'm going to cross this out and drop down a 12. Always have a root sign. And then what was left? Times 2. And that's my final answer. All right. I'm going to give you about 3 more examples, and then I think we're pretty good here. So example 14. I'm going to start getting into actually solving large equations. Okay. Now, some of my groups did not do this. Some did. So again, hopefully with this video tutorial, those of you who didn't get a chance to work on this assignment because it wasn't in your station, no worries. You just need to kind of know some of the basics here. So we're going to say x times x minus 3 minus 51 equals negative 3x plus 13. So now we're solving for the value of x. So the first thing we want to do is get rid of these parentheses. Again, anytime you have a number or a variable outside a set of parentheses, you have to multiply whatever's on the outside to everything on the inside. I call it double rainbow because you wind up making two rainbows here. X times x is x squared, not 2x. X times 3 gives me 3x. That's the only time you're going to get a 2x is if there was an actual 2 here. Drop down the minus 51, drop down the minus 3x plus 13. All right, so now what you want to do is start combining like terms. I don't have any other term that has a square, but I do have a single x here and a single x here, so I'm going to combine them. They're on opposite sides of the equal sign, so you do the opposite operation. So what's the opposite of subtracting 3x? Adding 3x. All right, so if you notice here, those cancel because they come out to 0. So do these. So basically, I got rid of my single x option. So I have x squared minus 51 equals 13. Now your goal here is to get that variable by itself. So I need to move this 51. I'm going to move it to the opposite side of the equal sign. So I'm going to take the opposite sign. So instead of subtracting 51, I'm going to add 51. These zero out, so they cancel. Drop down your x squared, and now we're going to add these up. So 13 plus 51 is 64. Now to finish this off, we need to take the square root of both. The square root of x squared is x, and the square root of 64 is 8. And that is your final answer. All right, let's try a couple more. I know that these are long and have a lot of steps, so I want to give you a couple more like this. So negative 3x to the third power plus 14 equals negative 67. So no distributive property on this one, just going to find out what x is. So in order to get this by itself, I need to get rid of this plus 14 first. Plus, I need to combine it with this like term. So what's the opposite of adding 14? I'm going to subtract 14. And you do this because you want this pair to cancel out. Now I have negative 3x cubed equals, now negative 67 minus 14. They're both negative, so I'm going to add them. But my answer will be negative. And I get 81. Now again, you want that x cubed by itself, so I need to get rid of this 3 to get that x by itself. This is being multiplied. Whenever they're slapped together, that means multiplication. So the opposite of multiplication is division. So I'm going to divide by negative 3 here and over here as well. These cancel. Drop down my x cubed equals, now 3 goes into 81 27 times. And a negative equals a positive. So now to finish this off, I'm going to take the cube root of each. The two cubes cancel each other, leaving me with just an x. And the cube root of 27, well, let me just make sure we touch bases with our calculator here, just to make sure you understand how to use it. Let me show you one more time. 27 cube root is 3. All right, so we pull this back up. And the answer is 3. All right, last one. Here we go. Example 16. So 216 plus x equals x times x squared minus 5 plus 6x. First thing I want to do is take care of this parentheses. So, double rainbow again. We're going to do x times x squared actually becomes x to the third power. You just add the exponents. X times 5 becomes negative 5x. Let's drop down that plus 6x. And we'll drop down everything that was left on this side. All right, I don't have any other x cubes, but I do have some single x's. So first, since these are on the same side of the equal sign, let's go ahead and combine those. Negative 5 plus 6 is going to leave me with just one x. So we just put plus x. Let's bring this all down. All right, now I'm going to combine my single x going across the other way. So I'm going to subtract x from both sides. And if you notice, those cancel, so do those. So all my x's are gone. And I have 216 equals x cubed. Finally have my x by itself. So now let's finish this off. I'm going to take the cube root of both. Those cancel, leaving me with x. And the cube root of 216 is 6. And that is your final answer. This concludes my video tutorial for our first set of standards, which was just standard 8.NS.1. Have a good night.